In this video, we learn what is a diagonal matrix and we'll find out how to reduce a matrix into diagonal form. So before going to define the diagonal matrix, we'll see what is the similar matrices. So the similar matrices is defined as if A and B are the matrices of same order, if there exists a matrix P, so then it has to satisfy a condition that A equals to P inverse B into P, or PA equals to BP, then the matrix A and B are said to be similar. And the result is, if the two matrices are similar, then their eigenvalues are same. Now we will define what is a diagonal of a matrix here. So A and B are said to be, now we will define what is a diagonal of a matrix. A matrix A is said to be diagonal if it is reduced into a diagonal matrix here. Okay. And according to this, if there exists a non-singular matrix P such that P inverse A into P equals to D, then D is said to be the diagonal matrix. And here P is called as a model matrix. This P is called as a model matrix, and D is called as a diagonal matrix, and also it is called as spectral matrix. And the result is, if the eigenvalues are distinct, then the matrix is always diagonalizable. Procedure to reduce the matrix into diagonal form. So first find out the eigenvalues and eigenvectors of a given matrix A, and then check the number of eigenvalues must be equal to the number of eigenvectors. Then the matrix A is said to be diagonalizable. Then find out the model matrix P, and here the eigenvalues will define it as what? Lambda 1, lambda 2, lambda 3, and we'll find out the eigenvectors as x1, x2, x3. Write the eigenvectors as a columns in a model matrix x1, x2, x3, and find its P inverse. Then finally write down the diagonal matrix as D is equals to P inverse AP. Calculation of higher powers of a matrix A. So we'll find out by using the diagonal form. So according to the diagonal matrix, we have here D is equals to P inverse A into P. To get a matrix A, so pre-multiply with P and post-multiply with P inverse. So this can be written as P into D into P inverse equals to P into P inverse A into P into P inverse. So this is equals to P into P inverse is I into A into P inverse is I. So therefore we get P into D into P inverse equals to A. Similarly, find out A square value. A square can be written as A into A, which is equals to P into D into P inverse, P into D into P inverse. So as a result, P inverse will be I. So D into P into P inverse. So D into I is again D into D is D square. So P into D square into P inverse. So this is the result of A square. So A square equals to P D square into P inverse. So similarly we will get A cube can be written as P into D cube into P inverse. So continuously, so generalization, so A power n can be written as what? P into D power n into P inverse. So this is the formula to calculate the higher powers of a matrix A. Let us see an example how to reduce a matrix A into the diagonal form and calculate its higher powers. The higher power is A power 4. So write down the characteristic equation. The characteristic equation of a matrix A is det of A minus lambda I equals to 0. So which can be found out by using the formula lambda cube minus the trace of the matrix 3 plus 5 plus 3 into lambda square plus sum of the minors of the principal diagonal elements. So that is 5 minus 1 3 minor plus 3 1 1 3 plus 3 minus 1 5 into lambda minus det A equals to 0. So on simplification we will get here lambda cube minus 11 lambda square plus 36 into lambda minus det is 36 equals to 0. Solve the polynomial So we'll get the lambda values. The lambda values are 2, 3, 6. So these are eigenvalues of a matrix A. To find eigenvector, for that you have to solve the system A minus lambda I into x equals to 0. Okay. Now first we will define what is A minus lambda I. 3 minus lambda minus 1, 1 minus 1, 5 minus lambda minus 1, 1 minus 1, 3 minus lambda into x1, x2, x3 equals to 0. Okay. Now find out eigenvector for each lambda here. When lambda is equals to 2, okay, substitute the lambda value in the above system. So we'll get a matrix as 1 minus 1, 1 minus 1, 3 minus 1, 1 minus 1, 1 into x1, x2, x3 equals to 0, 0, 0. Now, so here the lambda is a distinct value, so we can use the cross method. Previously we have discussed it. So that is given as x1 by, so neglect the row and column. So we write here 3 det of 3 minus 1 minus 1 1 minus x2 by, so neglect the second column and first row. So minus 1 minus 1 1 1 equals to x3 by, neglect the third column and first row. So minus 1 3 1 minus 1. So on solving we get here x1 by 3 minus 1 minus x2 by minus 1 plus 1 and x3 by 1 minus 3. So x1 by 2 minus x2 by 0 and x3 by minus 2. So therefore we can find the eigenvector x1 as x1, x2, x3 equals to 1, 0, minus 1 by taking 2 common. So similarly we can find out eigenvector x2 as 1, 1, 1 when lambda is equals to 3 and x3 equals to 1 minus 2, 1 for the lambda equals to 6. So we got the eigenvectors. For lambda equal to 2, the corresponding eigenvector is x1, 1, 0, minus 1. For lambda equal to 3, the corresponding eigenvector is 1, 1, 1. And for lambda equal to 6, the corresponding eigenvector is 1, minus 2, 1. So with the help of these eigenvectors, now we will form a model matrix. The model matrix is defined as P. The P is defined as what here? The taking the eigenvectors as a column which is equals to 1, 0, minus 1, 1, 1, 1, 1, minus 2, 1. Now find out its P inverse. On calculating, we will get the P inverse as 1 by 2, 0, 3 by 2, 1 by 3, 1 by 3, 1 by 3, 1 by 6, minus 1 by 3, 1 by 6. And now find the diagonal matrix here. The diagonal matrix is defined as D equals to P inverse A into P. So write down the P inverse. The P inverse is 1 by 2, 0, 3 by 2, 1 by 3, 1 by 3, 1 by 3, 1 by 6, minus 1 by 3, 1 by 6 into the matrix, given matrix A, 3 minus 1, 1, minus 1, 5, minus 1, 1, minus 1, 3 into the matrix P, model matrix P. 1, 1, 1, 0, 1, minus 2, minus 1, 1, 1. So on multiplication, we get a diagonal matrix here. The diagonal matrix are 2, 0, 0, 0, 3, 0, 0, 0, 6. Now we will calculate the a power 4. To find a power 4, so a power 4 equals to P into d power 4 into P inverse. Write down the model matrix P. 1, 1, 1, 0, 1, minus 2, minus 1, 1, 1 into d power 4. For diagonal elements, so make it power 4. 2 power 4 is 16, 0, 0, 0, 3 power 4, 81, 0, 0, 0 and 6 power 4 is 1, 2, 96 into P inverse 1 by 2 0 3 by 2 1 by 3 1 by 3 1 by 3 1 by 6 minus 1 by 3 1 by 6. A power 4 equals to 251 minus 405 235 minus 405 891 minus 405 235 minus 405 251. Thank you.